Okay, thank you guys for joining. Student over Zoom, can you hear me? Nice. Okay, I see more people coming. Good. All right, so today we'll cover chapter 4. And chapter 4 will talk about layer number 3. And this layer is called network layer, correct? Okay, so what we will cover in network layer? We will talk about two concepts, something called packet switching and circuit switching, and we'll see what that's mean. After that, we'll discuss the type of packet switching. We have something called connectionless, and we have something called connection oriented, and we'll see the difference. All right, to discuss how routers forward packet, the connectionless. Okay, we'll see that, and the same thing in the connection oriented. Okay, then the last thing we'll discuss some of the services provided by this layer. All right, let's go. So now, when you're trying to send something from computer to another computer, so between these two computers, there is a lot of connections. There is a lot of routers, switches, unless if these two computers next to each other and they connected directly. So I need you to think about what is between the two computers, kind of a black box. You don't care what's inside, okay? There is routers, switches, but you don't care. So what's your responsibility or your computer responsibility to send the data from application layer through all these layers, then through this black box, which is the internet, to the other computer. So how do you think about the internet in general? The internet is just a big black box. What's inside? You don't care about it. So the internet will deliver your message based on routers, based on the switches, based on the technology protocol. At the end, if you send a message from A, it will reach out to B. So that's how we would think about the internet. So if you have a message, usually if you want to send a message, usually it comes from where? Everything you're trying to send has to start from the application layer, from the higher layer. So you will create a message here, correct? And then it's going to go through layer to layer to layer to layer. Then through the internet, it's going to go to the first layer at the B computer, and then data link, then next layer, then next layer, then that's the final destination. Okay. All right. All right. So what inside this box? It's maybe 100,000 of routers connected all this internet in every single location in this world. Now, so here, what we're looking at inside this is that box. It's just a small network. Let's just say, you have a small network, has like 5 routers. That's the network. So you're trying to send something from A to B, has to go through routers. And how you would go through these routers? Who will decide which traffic you want to go? If you want to send something from A to B. So it has to find a way, either maybe it's going to go this way. All right. Maybe your network will decide, no, the best way to go, maybe this way, that's the fastest. Or it's going to go this way. So that's why the internet, or this black box, has the technology, has the protocols to be able to find the best path and send it to the B host. All right, simple. So, okay, I'm sorry. Perfect. So now, how you will decide which way I want to go? Okay, so how you want to deliver the message? Which router to router? That's why. Okay, so each router has multiple ports. So for example, let me go back here. Do clear. So for example, this router, the first router, how many ports you have? You have 1, 2, 3, 4, correct? So this router will decide, okay, I want to send this packet to, interface 2 or interface 4 or 1 or 3. So based on the protocols, and we'll see that later. So that's why what they call it, you call it switching. So you switch from router to router. So for example, I have a packet from here. It's going through this router, correct? Then what I want to do, I want to switch the route to this router. Then from this one, I want to switch to this one. That's why they call it switch, right? So now we will talk about two concepts. We have something called circuit switching. What is the circuit switching? Circuit switching is that's the old phone line. Remember phone line? You're trying to call someone. So what do you have to do? You will dial a number. So then when the other end answers the phone, what's going to happen? So you will be able to talk back and forth, which is mean this path, the whole path is reserved only for you. Nobody else can use the same path. Nobody will take the line from you and start talking and you wait. No. When you establish a connection between A and B, then the whole traffic is going to go between them. So nobody else can share that with them. So that's the old phone system. Is the internet work this way? No. Internet is a shared network. It's a shared bandwidth. So you have to share that with the other. So you cannot just reserve it and keep it for yourself. So in the old technology, in the phone system, when you connect, it's yours. Nobody can touch it until you stop talking, until you hang off the phone. You close the line, then now somebody else can grab the line and start talking, right? So that's called circuit switch. So physical switch or channel is established between source and destination. So it's a virtual channel. It's between these two. Nobody else can use that while you use it. After the circuit established, the entire message, it's sent. So you send back and forth. You keep sending. And after you complete, what's going to happen to this channel? It's going to be turned down. So now somebody else can use it. Simple. So in the circuit switch, the whole message is sent from source to destination without being divided into packets. So you're not dividing your message to small messages. So this one did not work with the network or the internet or the network. We are using something called, and that's example for the phone line. So that's what usually we do. So that's why we are using something called packet switching. What is the packet switching? Packet switching, you have your message. Your message is too big to send in one shot. So what you have to do? It's called packet. That means you packetize your message. You divide it to small pieces. Then what you have to do? You're sending one packet at a time. Small packet, send. Second packet, send. Why you do that? So to share this connection or this internet with the other. So when you send these small pieces, then you send the first piece, it's yours, but somebody else can send another one. So you're sharing the connection. So it's not everything is for you. It's not reserved only for you. So you can send it as divided. So message from the upper layer divided to a manageable small packets. All right, but they put it inside, the header. Remember the process, you add header, trailer, and you send it out. The source of the message sends the packets one by one. So I love University of Bridgeport. So I divided, I send it separate. Love, send it separate. Bridgeport, separate. Okay, now at the destination, what's going to happen? At the destination. So you will receive the messages. You will receive I alone, love alone, Bridgeport alone, right? So then what the destination will do? Put it together. Then I will send it to higher level, or layer until got to the application, correct? So that's why if you see this, the packet switching is the message. The message is first divided into manageable packets, right? Add the source before it's transmitted out. The packet are assembled at that destination. Now, for question for you: when you send these messages, when you divide it, for example, to 5 messages, message 1, 2, or packet 1, 2, 3, 4, 5, is guaranteed to receive it at the destination as 1, 2, 3, 4, 5? No, it's not guaranteed, because each packet is going to follow maybe different path, and we'll see that. All right. So the destination responsible to receive all of them. After you make sure you receive all of them, then you sort them, then you put them together, then you send it up. Clear? Okay. We covered that already. So when we are talking about packet switching, so there is 2 types: connectionless and connection oriented. What is the difference? So let's say have a message is divided to 1, 2, 3, 4 packets. You divide it to 4 packets, correct? Because as we say, you have to divide it to manageable packets. You cannot send the whole message once. All right, so what you have to do? So your internet, the block box, it's gonna decided for some reason, decided to send packet 1 through router 1 to router 4. Packet 2 decides to send it from R1 to R2. Then packet 4 and 3 is going from R1 to R3. Then packet 2, it went to R2. Then from R2, it's going to go to R5. Packet 3 decides to go this route. Then packet 1 and 3 going to R5. Packet 4 is going here. So this packet is going in different path based on the router. The router will decide, oh, I'm going to send this packet this way, or this way, or this way. Based on, there is a lot of reasons. There is maybe this router is busy now. I cannot send him more packets. Let me find another path. Okay. So maybe this one is router 2, maybe it's far from me. Why do I want to go to router 2? Let me go to router 4. So we don't have to worry about it now. But the point here, so the first step is to divide your message to packets. 1, 2, 3, 4, depend on your message. So you divide it. Then you send it to the internet. The internet will decide which one. Then when you receive it, as we mentioned, are you guaranteed to receive it in the right order? No. So that's why if you see we receive 2 first, then 4, then 3, then 1. So now when you receive it at the physical layer, at data link layer, where you give it to? Network layer. Now what is the network layer at the destination will do? Simply we'll sort it, put it together. We'll make 1, 2, 3, 4, 5, put it together, and then send it to transport layer. All right. So why is this one called connectionless? You will know the answer when I explain the connection oriented. It's going to be more clear for you. So now, how the router will decide which way I want to send the packet. So the router, as we mentioned, how many? Where's the pointer? Somebody took it. Oh, actually here. So now here's the router, correct? This router, how many interfaces you have? You have 1, 2, 3, 4. So how you will decide if I receive a packet from here? How I will decide? I will send it to 2 or to 3 or to 4. The interface. How I will decide? It's based on the table. Each router has a table. So this route in the connectionless connectionless, what we are relying on, the destination. So I'm receiving a packet here. It's telling me the destination is A. So I will go to the table. I know the destination A, then I have to send it through interface 1. So it has to go this way. If the destination B, I have to send it through 2. If the destination H has to go, destination 3. And maybe you have too many connections, depending on your network, all right? So that's how you decide which way you want to send the packet. It's based on the routing table and based on the destination address. That's very important because on the exam I will ask you. If the connectionless, the delivery decision is made based on destination address. Right? Very important. And in the connection oriented, it will be different. I will show you. All right, so I'm trying to send data from, that's the source, the destination. So I receive the packet here. My router, what will do my router? Will go read the table. So the destination, I will check the destination. I'll go here. Okay, the destination, let's say, no, this, I'm sending that to where? What do you think? I'm sending to that to B. So let's say, no, here is the address of B. Let's say, no, they wrote B here. Usually it's not A and B, C. Usually it's an address, correct? So let's say, no, it's B. So what that means, where I have to send the packet, through 3 or 4 or 2. From the table, I can do has to send it through this way. All right? Then you send it out. Then this one, where this one it's gonna go? The next router. The second router will do the same thing. I will open it, see what is the destination, then I will check my table. I will see where is this destination, which interface I want to use, then send it to the line. Okay. All right, so when you see blue, that means it's coming in the exam, correct? Make sure all of that. In the connection list, packet switch network, the forwarding decision is based on the destination address. I mentioned that to you. All right, so let's look at the time. When you're trying to send something from A to B, and if you have a connection list, what's going to happen? That's your message, correct? You send it to the first router, the closest router to you. Then, based on the table here, it's going to send it to next router. Then it's sending the destination. Maybe you will have more than 2. Maybe you have 5, 6, 7. It's going to be the same thing. So the question for you: why we have a waiting time? Correct. So because here in this router, what this router will do? I will open the packet, correct? I have to see where is the destination, final destination. Based on that, I will open it, and I will read what is that destination. I will modify the packet and send it to the next one with the new ID address or the address next to it. Remember, the physical layer or data link layer, we care only about the physical layer or the address of the machine or the device next to it. I don't care about the final destination. I don't care about B. I care about the device next to me. Right? That's why I have to find the physical address of the next device. So that's why you will have a time here to do some process. That's why there's a delay. Okay, so you will have a time in here for the router to do something. Same thing here, you have a delay for this router to do something. So how much the total delay? Or how much it takes to send something from source to destination, from the beginning until you receive the last packet. Clear? Now let's talk about connection oriented. What is the connection oriented? From the name, you feel it's like more organized. So in the connection oriented, before you send any message, so what you have to do? You have to establish the path. So I have to go find the path which I will send my data through. So that's why it's a 3 phases. The third phase 1 is establish the connection. I'm not going to send data. I will go and find my path. Then when you find your path, what you have to do next step, send you all the messages, all the packets. And after you're sending all the packets, what you have to do? You just tear down the connection. Right? So if you read here, after the connection setup, the datagram can be, follow the same path. So what's going to happen? Remember in the connection list, each packet is going to maybe go to different path. Now in the connection oriented, what's going to happen? All the packets is going to follow the same path after you find it. So let's say, I went through the network. I decide to go from router 1 to 5 to 7 to destination. So now all of them is going to follow the same. I will show you the picture. Okay, in this type of connection, not only most of the packet contain the source and the destination. So here, To be able to do that, you have to find this path, and you have to add something called label, and we'll see how we do that. So now you're not just relying on the source and destination address, you are relying on something called label. That's one of the questions in the exam in the correct connection-oriented. How you decide which path you want to follow based on the labels. I will show you that. So now I'm trying to send something from source to receiver. So first step, I have to go find the best way to go to the receiver. So I decided, for some reason, I decided to go from router 1 to router 3 to router 4, then to the receiver. So if you want to send something, okay, you want to send a message, so you divide it through packets, then you send them. So you send them 1, 2, 3, 4, you send them again 1, 2, 3, 4. Then from router 3, it's going to go 1, 2, 3, 4. Then it's going to go 1, 2, 3, 4. So it will be sent and received in the same order. Okay. So the connection list packet switching network, the forwarding decision is based on label. Okay. So I will show you how we create the tables. And that, to create a connection-oriented service, a 3 phases process is used: setup, data transfer, and teardown. So in the setup phase, what you have to do? The source and destination addresses of the sender and receiver is used to make table entries. That's very important. We'll show you how the table gets created initially. So let's say you have a message to send it from A to B. Initially, the table, okay, it's empty. So you have to build this table. That's called the setup phase. After you finish everything, you delete this table. After you send the data, then you delete the table. And I will show you that. All right. So in this table, let's say now the table already created. So for example, I'm trying to send something from source to destination. So usually when you start sending, it will have a label. So then you will look at the label. So you will see it's income, because that's the router. The income here, it's called label 1, and it's coming through an interface 1. It has to go through port 2 and label it as label 2. Okay, then the message you're creating, what you did here, you replace the L2 with, I'm sorry, L1 with L2. So you add a new label. Why you add a new label? Because the next router has to open this packet and see the labels coming. Then they will have another table like this, but maybe it's going to send it to different ports. We'll show you now when we have created. So here, what we did here, we did not rely only on the source and destination address. We rely on labels. Question for you: if you are using labels, why you have to send the destination address? Why you have to send it? Keep sending them. Why you not just ignore it if we are relying on the label? So, because we have a huge internet, so some of this router maybe it's configured to use connection. So not all the routers may be using the connection oriented. So if you're doing it through a router, one of the routers is connectionless, you already have the data there. So you have the destination address. So then they can do the job. All right. So that's why the internet is mixed between connectionless and connection oriented based on the site or the organization or the vendor. Now, let's see how we create the table. So what I want to do, I want to add, I'm sending something from A to B. So initially this router table is empty. This router table is empty. This router table is empty. So the first step, what you have to do, you have to do the setup. So how you do that? Is this one? Oh, so I'm sending something from A to B, correct? So what's the table it's going to look like? Is this one working? Okay, so maybe it's not connected to the computer. Okay, no problem. I will do it here. So router A and B. So this router R1. So what we'll do? So the data is coming from port 1. What I will do, I will give it a label 14. This router will decide. I want to just give it label number 14. Then this router decides to send the data through interface 3. Now, you leave this one blank because you don't know what's the label it's going to be. So then what you have to do, you forward the message to next router. So it's going to go from router 1 to router 2. Now router 2 has to do the same operation. So what's the router 2 will do? We'll see, oh, the data is coming through interface 1. I will give it label number 66. And I will send it through interface number 3. However, I will leave this on the cloud. Okay. Then it's going to send it to R4. What's R4 will do? Same thing. It's coming through interface 1. I will give it label 22, and it's going to go through interface 4. Then it will be delivered to B. Now, what B will do? What will we do? We will do acknowledge. We say, I receive your request. I will send an acknowledge. So in this acknowledge, what I will do, what this computer did, I said acknowledge with label number. So what's going to happen to the 77? Going to be added to this table. Now I'm sending the packet back, and I decide to give it 22. Then what's up? I don't know what they did. Wow. Then I will add the 22 here. Then from router 3, I'm sending something back to R1, and I decide to give it 66. So what I have to do? I add 66. Then what we have there? 66. Now, then I send the 14 because this has 14, because I know the interface 1 has 14. So now that's your setup connection. That's what it is, setup. So you will have table, table, table. So now what is the next phase? What you have to do after that? Sending the data. Now, how you send the data? See how it's gonna, how the router will decide. Simply, I will send the message. Remember, the message, it's gonna add a label to, that's the add source address, the destination address. What I will add, label 14, correct? So now, when the packet comes to R1, what's the R1 will do? He will go find where is the label 15. Oh, that's label 15. What I will do? I will send it through 3, and I will change the label to 6 symbol. Then the packet is going to be renamed 66. Then this router RP will do. Let me find the label for 66. What I will do? I will change the message. I will add label 22. I said now 22. Now router 4, what we'll do? I will find this label, which is 22, and I will replace it with, what's going to happen? 77, it will go to the destination. All right. So that's why, and the connection oriented is divided to 3 phases. Setup, here. Now, now I send the first packet. Is that done? Can I carry it down? No, I will keep sending until I finish my message. So after you finish your message, what you will do? Mute yourself, please. Okay. So now, let's see the timing now. So first phase A.
Okay, done.
Can you please mute yourself? All right. Okay. All right. So the first phase is the established connection. How you establish connection? You send the request. Then after you will get an acknowledge back from. Then You go in front. What is 2 steps called? Setup. Then I will send data. Is there a waiting time here? Is there a time delay? No, there's no delay because your router will know to send it right away. They will know the same path. You send the first packet, then the second packet the same path, third one the same path. Then after you finish, what you will do? So I will send, I'm done. Then the source will tear down the connection. That's the tear down connection. Perfect. So now, is the delay here less or more? More. Why? Because you have the setup, and you have the tear down. Now, what's the advantage? What's the advantage? The same sequence. You follow the same path. So if you decide this path is the best and fastest, so that's going to save you time. It's going to save you what they call it. If you know some of, because you know when you have internet, some of the routers sometimes it goes down. So if you want to just rely, send it to everybody, and if you got to the router is down, then has to go back and go to different path to find another path. But here in this case, first you will go explore the network. Let me find the best path for my data to go through. So it will be guaranteed that is the best and established or a stable path to send your data. All right. All right. So now when you have routing failure, so you will have a source and destination, but if you want to send something through the internet from router to router community switch, so it's going to follow the same process. What's going to happen here? I'm sending something from Elise to Bob. So simply it's going to go this computer, it's going to go through 5 layers. Now this router, it's going to go through 3 layers. Remember we mentioned the router, have only 3 layers. Then from this router, maybe this one, it's, you know, internet provider. So it's going to go 3 layers. Then another provider, it's going to go 3 layers. So it doesn't matter what type of the network type here. You will go 3 the same 3 layers. You have to go in, go up, go down. Same thing, go in, up, down. So it's going to go to the same scenario until you reach to the last computer. When you reach the destination, it's going to go through 5 layers. So that's happening in every single, you know, transfer data. That's what's happening exactly. So now, what exactly happened in the network layer? Okay, so simply, so remember when you have a source, you have a destination, correct? Both of them they have network layer, and you will have in the middle. If you have a router, is there a network layer? Router. Does the router have a network layer? Yes. Router has 3 layers, network layer. So that's mean, you know, at the source, you will do a specific function. At the router, you do a specific function. At the destination, you do another function. So in the source, I'm sending data. So this data, that's my data. It's coming from where? Transport layer, right? So it's going to, that's my network layer. So what you do inside the network layer? Remember the first step, what we have to do? We have to divide it to a small packets. That's the first function the network layer do. After that, what is the network layer will do? So find the next hop logical address. Okay, I'm sending my data from A to B. Okay, however, I have to go through the router 1. So first you have to find what is the router 1 address. Logical address. Okay? So that's why we have to find the next hop logical address. So there is a table. That's why we go to the router table, and we can find what is the next address. Okay. Next step, we have to find, after we find what is the next device IP address, what we have to do? We have to find the actual MAC address or physical address. And there is a protocol called ARP, and we'll discuss that in our chapter. ARP stands for Address Reservation Protocol. I think we will see what that means later. So that's why after you find that IP address, Then you will find the MAC address. Then after that, again, there is same thing. There is rules there. So on physical layers, some of the physical layer, you cannot send the whole packet. If it's big enough, it's too big to send it. So what you have to do, based on this one, there is a flag in physical layer. So network layer will go check. There are something called MTU, maximum transfer unit. So let's say I'm sending something through wireless. Maybe this wireless only can handle 100 megabytes. So what that means? That means I have to divide my packet to fragments, the smaller pieces. So let's say, let's decide you decide to divide it to multiple ones. You divide it, then what you have to do is send one value. So that's the source. And the source, what you did, factorize, find the logical address, find the MAC address, then fragment, then send the data. Now, what is the next device I'm going to check? Router, right? Unless if the next device is the computer. If you have only two computers connected together, that means there is no router. So we don't have to worry about that. But 99.9999 you will have a router. So what does the router do? What's the router function? So the router will receive, that's the fragments coming to the router. Remember, the router has to go from physical, go up to the network layer, then go down again. So you will receive the first fragment. So what you will check, is this a valid datagram? Is this data corrupted, missing something? If it's missing or corrupted, what you have to do? Just drop it. If it's it's not corrupted, what you have to do? Then when you go bring it here. So what you will do here, you don't have to do with fragment because the data you receive, it's already the smallest pieces. That's what you do. So what you have to do, you have to find what is the logical address of the next device. Maybe it's a hub. Maybe it's a switch. Maybe it's a router. Maybe it's a computer. So what is the next device? Then you have to find the logical address. When you find the logical address, always you have to find after that the physical address. Again, the same, we use the same algorithm. Then maybe you add more data. Since we're sending, you add and change it. Maybe you have to divide it for a fragment. So then you fragment, then you send it to the next device. So from router to router, you repeat the same operation. Let's say I have a computer, router, then another computer. So the first stage, this one from the computer, inside the computer, your computer. Now this one inside the first router. Now what about the second router? It's going to be the same process. Now at the final destination, at the last computer, what you have to do? You received all the packets. What you have to do? So what we will do, I receive the data. What I will do, I will check. It's corrupted. It's corrupted. Then after that, open the packet. Then what you will do is store them until you receive all the fragments. After you receive the fragment, if you receive all of them, you reassemble and then you send it to other layer. If you don't receive all of them, what you have to do? I receive only the first packet, second packet. I did not receive all of them. What you have to do? Wait until you receive all of them. However, you cannot wait forever. Maybe one is lost. Maybe you will not receive it at all. That's why you will have something called timer. I will wait for a certain time. I'm not going to wait the whole way to receive it. Maybe one lost through the route. So you cannot know. Maybe you don't know. Usually when they send you a packet, there is a flag. They will know the sequence number, if that's the last one, that's the first one, that we will see it later. But you cannot wait for one. You have to wait for a time. If you do not receive all of them during this time, what you have to do? Throw them in the garbage. All right? Clear? Simple. That's a network layer. Network layer, divide the packet to the message to packets and send it through the internet. Maybe it's connection oriented, maybe it's connection the destination. I will wait for all of them, put them together and send it to the client. Now, let's see if, so usually there is a few things, to be able to control the traffic or make sure, everything is delivered correctly. You need some of the services. Why we need error control? Why we need error control? Because you want to check if there's an error in the method. Why you want to check it? That's, you start and ask the sender to send it again. Why you need a flow control? To provide the overwhelming the destination. So now my computer is fast. I can send 1 gig, 5 per second. Or the destination can only receive 100 meg. So that's why you need a flow control to tell the sender slow down. I'm busy, slow down. So that's why you need a flow control. What about the conjunction control? Same thing. If you have a conjunction, you have to tell there is a conjunction. Then you can ask everybody to stop, wait. Why you need routing? Because you have to find a place. You need security, right? Now the question for you is the network layer provide some degree or not? So that's the error control. So what is the error control? It's a mechanism to detect corrupted loss or duplicate diagram. If it's duplicate, it's easy. What you have to do? You just discard one of them. If you have the same packet received twice, you just take one and delete the others. So error control also indicates mechanism for correcting errors after they have been detected. So sometimes some of the error you can fix it. You don't have to resend the packet. There is algorithm. Remember last week when we talked about CRC? CRC is an algorithm. If you receive a packet and this CRC it's kind of a math calculation, you will be able to fix, if you have a fixed switch from one to the other during that transmission. Anyway, so error correction is not providing a network layer. Network layer is not providing an error correction or detection. So where this key function or this function, where this one happens is the higher level or at the data link layer. Remember when we talked about CRC and the data link layer, we want CRC. So data link layer provides some of the error detection, and the transport layer, when we talk about it, it provides that. Data layer does not provide an error detection. So that's one of the exam questions. Next service. Okay. Remember in the network data link layer, when you send something here, we have an error check. We have CRC. So here, you can know if there is any error. Now inside the router, no error check. Now from this in this lane, we have error checking. Remember in the physical layer, data link layer, we have error checking. Here there is nothing. Here yes. So why we don't have it in the network layer? I think there is no need, because this one it's already a check if there is error. Here you can check. Here it is. If something happened inside, it's going to be rare. But if the router receives the packet, usually nothing can happen to the packet. The problem where the problem usually happens through the transmission. When you transmit the data, usually here it's having the corruption or some of the data loss, or maybe one of the bits switched from 0 to 1. So that's why you need it here. Here you need it. Okay, flow control. Next step. Same thing. The short story here. Okay, that's the idea for the workflow. You want to make sure the destination is not overwhelmed. Okay, you don't want to kill the destination with traffic. So that's why you need a flow control. So no flow control is providing the current version of the internet flow. Perfect. So in the exam, I will ask you, does network layer provide an error detection? The answer will be no. Does the network layer provide flow control? No. Perfect. Okay, that's chapter 4. It's quick, easy, simple. Not much there. All right, let me start chapter 5. Chapter 5, it's longer. I will do half of it. I'll let you continue. Does it need a break for 5 minutes or? 5 minutes? Okay, go ahead, 5 minutes. Is there any question about chapter 4? Network layer? Easy chapter. That's really an easy one. Okay, chapter 5, we will talk about IP address. So as we mentioned before, IP address, we have two versions. We have version 4 and we have version 6. So version 4, it's 32 bits, and we'll see how that's look like. So what we will cover in this chapter. So in this chapter, we'll introduce the general and address space. So we'll see how the IP address for divided. And after that, we'll discuss the block of address available in each class. Then about the hierarchical, like when you do a sub network and super network. Then next week, we will go over about the classless addressing. Then same thing, we'll discuss the special block and the special address in each block. Then after that, we'll talk about a concept called NATing. All right. So now the TCP/IP, in the TCP/IP suite, we are using a logical address. Logical address is the IP address. We call it IP address. And IP4 is 32-bit address. It's a unique address within the network. So you cannot have two computers have the same address. If you live in address, okay, you cannot have two addresses in your address. So it has to be one unique. So usually how the IP address divided, it's divided to 4 sections. And each section represented by 8 bits. So it's usually, for example, 10.10.10.10. So how many sections? 4 sections. And how each section represented by 8 bits, correct? So total will be 32. All right. So as we mentioned, a 32-bit, each address defines one and only one connection to the internet. One address for every single computer. You cannot use the same address for 2 computers. Okay, universal, the addressing system must be accepted by any host that wants to connect to the internet. Right? So if you want to send something to host B, you have to have a valid address. If you don't have a valid address, then you cannot be connected. Unique and universal. That's one of the questions in the exam. All right. So if the address is 32 bits, how many addresses we can have? How many? Simply, it's 2 to the power 32. So that means you can have up to 2 to the power 32 addresses, computers, devices, hosts. That's why, I don't know, that's 4 trillion, I don't know what's the number, but it's a lot. So that's what we have. Do you think that that's going to be enough in the future? Maybe not. That's why we start using IP6. So for now, we are using IP4. All right. Number is based on 216 and 256. Okay. We'll show you that later when I explain that. All right. So simple example. So that's an IP address. Either you write in binary, or you write in decimal. So that's how many bits you would have. And it's in digital use 0. So you can represent each bit. It's going to represent a decimal. So this number is equal to 28. This 8 bits, it's 8. This one is a 3, and this one 31. Can you tell me? Do you know how to find the number from binary to decimal? Yes or no? 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 How many nodes? Okay, so simple. I will give you an example. I wish I have a good marker. I wish. Is there any more? Let me see this one. Yeah, that's good. So let me take section number 11. What's how much? What's the bits? Okay, 11. Which it's 0, 0, 0, 0, 1, 0, 1, 1. Correct. So in binary, it's really simple. If you want to find this decimal, how you can count? It's really a simple addition. So this one, write it in decimal. It's usually 1, 2, 4, 8, 16, 32, 64, and finally 128. Correct? Then just add the numbers as 1. So which number has 1? 1, 1, 1. So what is the number? 1 plus 2 plus 8. That's equal how much? 11. Perfect. So the trick always just to know this sequence. So now if you give me the second one, what is the second one? What is the second one? I want to do it on the computer. I didn't do it here because of the student there. So let's do that. So now this number is X. Okay, perfect. So always technical. So this number, as we said, always remember to do that. 1, 2, 4, 8, 16, 32, 64, and 128. So what is this number? Just any, if you have 1, just add these two numbers. So you will have 1 and 1. That means this one and this one, which equal 1 plus 2 equal 3. Perfect. What about this one? If you wanna find this one, how many ones? 1, 2, 3, 4, 5. So that's mean 1 plus 2 plus 4 plus 8 plus 16. And if you add them, that's gonna be 31. Perfect. That's how you convert it from binary to decimal. So again, the IP address for it's 4 section. Each section represented by 8 bits binary. Simple. So now in the exam, if I give you an IP address and I tell you just convert it to decimal, how do you do that? So I'm not going to do all of them, just we can, select one. Let's do this one, for example. Simple. Okay, let's start with this section. When all of them is ones, what is the total? 256. So correct, 255, because it's from 0 to 55. It's 256 numbers, but from 0 to 255.
So this one you see is 255. All right, let's try the second one. What is the second one? This one is 1 plus 2 plus 8 plus 16 equal 27. Perfect. So that's why we have 27 here. What about, let's pick up easy number. What about this number? What is this number? It's 1 plus 2 plus 4 plus 8 equal 15. Perfect. So it's a symbol. You just take 8 bits and convert it to decimal. And you have the answer there. Now, next question, the opposite. It's really simple. You know, how you want to convert this one to binary. So if you go to the C, this one, it's equal 12. How you know it's 12? It's 4 plus 8. It's 12. Okay, let's pick up another number. I'm not going to do the big hardest one. So 8, for example, 8. That's 8. So how you going to convert that to decimal? To binary? It's really 0, 0, 0, 1, then 0, 0, 0, 0. Easy. Is there any questions so far? So in the exam, I will give you numbers in binary or ask you to convert it to decimal. And I will give you decimal, ask you to convert it to. All right. Now, question. Don't read the answer. But so as we mentioned before, it's 4 sections, and each section represents 5 things. So now, if I will give you the first one, what's the issue in the first one? Don't look to the answer, please. Try to think. What is the issue here? You see the 0? There is no need to write 0 there. Just to put the number without 0. What's the issue in this number? How many sections? 5. That's why you have 5 sections. You're supposed to have how many sections? Okay, what about this number? Maximum you will have 255. If the 8 bits 1, 1, 1, 1, 1, 1, 1, 1, 1, it's equal to 55. So there is no way you have an IP address has more than 255. Okay. What about this number? Because it's mixed. You cannot either use binary for everything or use decimal for everything. Hello? Zoom, can you hear me? Test, test, test. Yeah, I have issue with the mic. Is there any question so far? Good. So sometimes IP address is written in the hexadecimal. So let me show you. So either you write it in decimal or binary or hexadecimal. Hexadecimal is really easy. So remember the 8 bits, each one, we divide it to 4 of them. And if you remember hexadecimal, how many numbers we have in hexadecimal? 16. 0 up to 9, then A, B, C, D, E, F. So for example, now this number, what we have to do with this one, you divide it to 2 sections. You divide it to this 2. And this number in hexadecimal, what? Can you tell me? It's F, 15. In hexadecimal, 15 is equal F. What is this number? It's 14. What's in the hexadecimal 14 equal to E? So that's why if you see here, the address is FE. Same thing, you have to do the same thing here. So when you find it, you write it like this. Then at the end, what you have to write. So now to tell me that the hexadecimal, there is 2 ways to tell me it's a hexadecimal. How? Either by adding before the address is 0x, then I will know it's hexadecimal, or just I will add small 16 at the end. then I will know it's hexadecimal. Same thing in the exam. I will give you a number, binary number. I will ask you to convert it to hexadecimal. I'm not gonna give you you will not do it by yourself. I will give you multiple choice. It's gonna be confusing, but it's gonna be multiple choice. All right, another easy question. Now, okay, find number of addresses in the range if the first address is 146, 12, 29, and the last address is 146. Okay. So how much now? If I give you two IP addresses, I'll tell you that's the range. That's the first address, and that's the last address. How many addresses we have total? How you can do that? So what you can do? So first of all, you will find what is the common one. So you see this two number 146, 146. So we don't have to worry about them. 102, 102. We don't have to worry about them. Okay, what's the difference? 29 and 32 and 0 and 255, correct? So how we can do it? It's really simple. By, okay, since those the same number, that means if you subtract them will be, what's the subtraction will be? 0. It's going to be 0 to the power 4, because it will have how many, I'm sorry, 2 to the power 3. How many sections we have? We'll have 4 sections from 0, 1, 2, 3. So the first section, this one, is represented by 2 to the power 3, or 256, because we talk about decimal. So it's going to be 0, because we subtract 146 from 146 is 0. Then it's 256 to the power 3. The second number is 102, 102, 102 is, what's the subtraction equal? 0. So that's why we have 0. And it's this next, the second one is 256 to the power 2. Now then, 32 minus 29, 3. That's why we have 3. And multiply 256 power 1. What then? 255 minus 0. So 255 to the power 0. So since you 0, 0, that's 0. 0, that's 0. Now 256 power of 1, it's a 3 multiply 256 plus 255, 256, 255 multiply 1 equal. Then you add 1 always. Why we add 1? Because always when our range starts from 0. If we have 256 IP address, okay, that means the addresses start from 0 to 255. That's why we add 1. So how much the total? 1024. All right. So that's, maybe it's gonna come in the exam. I'm not sure. Maybe similar. It's not gonna be the same number. So I will give you 2 addresses. I will ask you find how many addresses we have. How many, the start address and the end address, how many addresses total we have. That's how you do it. All right. So another example. The first address of range address is 14, 11, 45, 96. If the number of addresses in the range is 32. So and this one is different question. So I will give you first IP address. And I will tell you we have 32 addresses. What is the last address? So that's the question. So how you solve this question? How you solve it? So 32, if you remember, when we have I have 32 addresses. What is the actual addresses we will have? From 0 to 31. So in this case, what is the first address here? That's the first address. So how many you want to add to this one to find the last one? 32, correct? So in this case, how you 32 you convert it? You convert it simply to 0, 0, 0, and 31, because as again we said from 0 to 31. Just we add them. 0 plus 14, it's 14. 11 plus 0 is 11. 45 plus 0 is 45. Then finally, 96 plus 31 is 127. So I give you the first address in the range. I told you my range has 32 address. Find the last address. How you find the last address? Using this equation, simple equation. The trick always, when you see 32, that's mean is -1. 32 minus 1. Why? Because we start from 0 all the times. Yes. $255. So that's mean okay. That's yeah. In this case, when you exceed, you have to go back to the previous previous section and take one of that and do the remaining. So when you do it, I have to give you an example for that.
Yeah, so all the way in the front, next.
Yes. Hello.
Yeah, but Macy's card is the phone number.
Are they talking to me or no? All right. So it's a complicated equation. I'm not gonna really focus on the example of that, but simply if it's exceeded, you have to, how you do subtraction or addition, you have to go back to the next section and take one from that or add one to that. Okay, I can explain it to you after the class, but again, it's going to be simple equation in the exam. I'm not going to go crazy about that. And maybe the answer is going to be is not valid. Why? Yep, it's going to be not valid. So if you try to add them and the addition it's exceed the 255, it's right away you say that's not valid. That's a wrong range or wrong number. So let me try to do it here. So your question, let's say my address is 14 11 45, correct? And what we have here 96. Let's say it's 230, for example, correct? Now I tell you, the first address is this address, and I'll tell you I have my range is 32. So what's going to happen here? What you will do? You will do 0 0 0. Then what is the last one? 31. So when you do the addition, it's going to be 14 11 45. Then what's the address here? 261. So tell me, no, your range is not correct. You cannot have 32 addresses here. You already exceeded, right? Next. All right. Let's talk about some operation. This operation is going to help us to do some math later. So when you add two binaries, I have to do it here. Or I'm sorry, before the two binary, let's cover the NOT. So if you have in the NOT, if you have 1 and you add it to a NOT or inverter, what's the result will be? 0. If you have 0, it's going to be 1. So in the NOT operation, the 0 will be 1 and 1 will be 0. We will see that why. But remember that's the operation. You have 32-bit. You put it in NOT, then just you will change the numbers from 1 to 0, 0 to 1. So for example, let's say when I have number, for example, that's 8, correct? I'm sorry, that's 15. So if you invert it or make it NOT, what's the answer will be? 0 0 0 0. So it's gonna be 0. If I change that to 1 1 1 0, what is the NOT for this number? It's gonna be 0, 0, 0, 1. Why we not learn that? We'll show you why. All right, so symbol operation. Now I'm trying to do a NOT for these two numbers. That's a 32-bit address. I want to do the NOT. What do you have to do? The 0, 1, 1, 0. So 1 is 0, 1, 0, 0, 1, 0, 1. So you do the flip. So, and for example, okay, that's if it's binary. Now, if I give you just numbers, okay, how you will find the answer right away without converting that to binary and do the flip 0 to 1, 1, 0. How you can do that? So what is the 32? What is the correct? So the maximum number, how much we have? 255. So what is the NOT of the 35? Is the remaining balance of the 255. Simple. So 35, 255 minus 35 is 220. 14. 255 minus 15. So in the exam, we don't have to convert it to binaries. Then give me the answer. Then convert it back to decimal. No, right away. So you know my max is 255. What is the total of these two numbers to make 255? Is the difference. So 255 minus that. So that's the NOT operation. We will know why we need it. Later we'll see why we need the NOT. Okay. Next operation is AND. What is the short answer for the AND? What's AND do? AND. If both ones, the answer will be 1. If one of them 0, the answer will be 0. Simple. Both ones, the answer will be 1s. Other than that, will be 0s. So that's digital design. So if I give you non-binary, if I give you this not binary, and I ask you to do the AND, simple, find where's 2 1s and write 1. Everything else 0. So here, I will find if this 2 1s. Is there any 2 1s here next to it? This 2 1s. That's why I wrote 1. This 2 1s, I 1. This 2 1s, I wrote 1. This 2, and this 2, and this 2, and this 2. That's why I have 1s. And this one 1s, and this one. Everything else is 0. Simple. All right. So that's if you want to do binary. If your number is binary. Now, if you have decimal, how you will know what is the AND for any number? Simple. The answer is really easy. So you have two scenarios. If you ending with 255, what that means? That means everything is 1. So that means if you end it with 255, it's going to be the same number. So 17 with 255 is 17. Now, what about if you end it with 0? What's the answer will be? 0. That's when you're taking the lowest. Always, if you have two numbers, number and 255, which one will take? The number. Now, if you have a number and 0, what you will take? 0. Just leave the lowest. Simple. Now, if you have the two numbers is not 0 or 255, now we have to do the operation. So, for example, here it's easy. Right away, we can tell is the 17. Here, it's easy because we can tell is 0. Here, it's easy. Why? Because we can tell is 255. Simple. Now, the issue here. So, in this case, what we have to do? So, we have to do this operation. So how is this operation? Okay, simply, okay, you will see the 14. So the 14, you will write it in decimal. So the 14 is 2 plus 4 plus 8. Everything is else zeros. Now what about the 140? The 140, when you convert it to decimal, it's 4 plus 8 plus. I'm sorry. Not this two. Oh. Let me do it again. So it's going to be 4 plus 8 plus Wait. Now, what is the next step? You select the numbers it's equal. Both of them, they have the same numbers. Okay, here is 0. 2 with 0, 0. 4 plus 4 and 4. So 4 and 4, it's going to be 4. 8 and 8, it's 8. 0 with 0, it's going to be 0. 0, 0. You just add them. 0 with a 28, 0. Because you remember when we add 0 with any number, it's going to be 0. So finally, what you have to do, just add them together. 4 plus 8 plus, that's it. It's 12. I'm sorry, 8 plus 4, it's 12. So that is the and for number between 14 and 140. Perfect. Why we need that? We'll see why. But now I'm teaching you the operation. So we covered not, we covered and. Now what about the or? So the third operation, it's called or. What is the or? Simply, if both 0, 0, if one of them 1, 1. Perfect. So how we can do the math? Simple. If it's binary, just you have to or them. If one of them is 1, just put 1. If both of them 0, we'll put 0. For example, here, both 0, so that's why it's 0. So in this case, just go find if you have 2 zeros and make it 0. Anything else, make it 1. Perfect. So here, what I will go find 2 zeros, zeros, zeros. Then that's why I will have 0, 0, 0. That's for binary. Binary is easy. Now for numbers. So numbers is the opposite. If you or a number with 255, what that mean? You will take the highest, 255. If you or a number with 0, what you will take? The number, not taking the 0, right? So this two cases. Now, that's why if I want to do this math here, from here, what is the or between 17 and 255? Now we'll take the max, 255. What about 35 and 0? I will take the max, 35. 121 and 255? I will take the 255. What about this two? We'll have to do the operation. Same thing. So, oh, I don't have it here. But it's going to be the same. Actually, we can do it here. Okay, let's do it here. So here, number, we have to do or. So that's two numbers, correct? So what is the numbers I will have? Okay, 0 or 0, 0, correct? 2 or 0, 2. So 0, 2. 4 or 4, 8 or 4, 8 or 8, 8. Because we'll take max 0. It's going to be 0, 0, 0, 128. If you add them, 128. I am muted. I am mute them. Then is he cursing me or what? All right. So 128 plus 2, it's 130, correct? Okay, 8 plus 4, 12, 142. Is that the answer there? It's 142, correct? So that's really operation you can do if you can practice. It's not really hard. Okay, we will see what we use it for. All right. Now, let's talk about now IP address 4. There's two types of address 4. We have something called a cluster, and we have a cluster. Today we'll cover cluster. So cluster, they decide to divide the IP addresses to 5 stations. So remember, if you heard about class A, class B, class C, class B, class C. So it's 5 classes, correct? The class A have all the IP addresses. They have. Class B take 12. Also that. Class C take 12.5%. plus C and E take 6.25. 6.25. We'll show you that. So that's how they decided. That's decided in 1990. All right. Okay. So as we say, it's divided to 5 plus A half plus B quarter, and plus C is 12.5. And the remaining, the 12.5 is divided to 2, which is 2, so 6.25 percentage wise. All right. So how many addresses for class A we have? 2 to the power 31. It's 2 trillion. I don't know what's the number. Plus B, it's going to be quarter. It's 1 trillion, for example. Plus C, it's going to be 536 million. Then class B is 268 million. And class E 268 million. You don't have to remember those numbers. I'm not going to ask you about numbers. All right. So how you will know your address is a class A or B or C or D or E? Simply, the first 3 digits or 3 bits, it's going to tell you if that's class A, B, C, D. So an easy one, class A always start with 0. Simple. Class B always start with 1, 0. Class B always start with 1, 1, 0. Then class B start with 1, 1, 1, 0. And class B start with 1, 1, 1. Simple. So that's one way how you know it's class A, B, C, D, E, F. The other way is to know the range. So the range, if the first section is between 0 and 127, you will know that's class. If it's between 128 to 191, it's a class B. Between 192 to 223 is class C. From 224 to 29 is a class D. I'm sorry, D. Then from 240 to 255 is a class E, correct? So try to memorize those because these those can help you in the exam to answer the question right quicker, so you don't have to do calculation. So in the exam, when you see an IP address start with 192 dot 10 dot 10 dot 10. What do we do? I will look here. Oh, 192, that's class A right there. Which one? D 299. Oh, I'm sorry. Yeah, so that's wrong. We'll see. We can do the math now later, but all right. The other way you can follow this flow chart. So you will take the first bit. If the first bit is 0, right away you will do it's class A. If it's 1, then let's see next bit. What is the next bit? If it's 0, I will know it's a class B. If it's not 0, still I have to look at the third bit. If the third bit is 0, I will know that's class C. If it's 1, it's going to be either D or E. Continue. I will look the next one. If it's 0, that's class B. If it's 1, it's class C. So you can follow this one, you can fill it. But for me, I try to memorize the range. I know from 0 to 127 is class A. From 128 to 191 is class B. From 192 to 233 is class. So I'll try to memorize that. So, question in the exam. I will give you this idea. It's okay, that's class A, B, C, D. First one is class A or B or C, D. Wait, don't look here. Class, first one. Class A, why? Start with 0, right away, you can tell. Next one, 110. What is this one? Class C. Okay. Third one, 101. Class B. Then the last one, E. You can tell right away. So it's really simple. I don't have to go over it. You can do it. The explanation here, but it's really simple. Next question in the exam. I will give you numbers. So if you remember the range, it's easy. Right away, I can tell. When I see 14, C. What's this one? Class A. Class A, right away. Why? Because we know class A between 0 to 117. What about 193? That's class C. Why? Because the class C is starting from 192. Okay, 252, that's a class E. Because it starts from 240 to 252. And the first one, 227, it's class. This one D, because between 224, The answer is 239, not 299. So here, I'm sorry. Again, that's I copy, that's from the book, so maybe they made a mistake. Like here, one should be 239. Perfect. Easy. Easy to know which address. So IP address A and B C divided into an. Okay, so that's good. So now the IP address. So now we know what's A, B, C, D, E, right? Now next we have to define what is the network address or the network ID and the host ID. So now if we have a network plus A, so the first 8 bit is going to define my network. The remaining bit is going to define the host. So that's meaning, okay, I can have, if it's plus 8, I can have 2 to the power 24 hosts in my network. Right? Because 8 bits, the first 8 bits is going to define the network ID. The remaining, the 24, is going to define the address of the host. So if you have 24 bits, how many addresses I have? 2 to the power 24. Okay. So that's why in the plus A, the first 8 bit is going to define the network ID, the remaining is the host. Now what about plus B? The first 16 bit is going to define the network ID. The remaining is going to define the host ID. What about plus C? The first 24 for network ID and the remaining for host. What about plus C? Sorry, E and D. E and D, they have only one block. They don't have device. They have device, but they don't have a network ID and a host ID. So it's one block. Plus C is reserved. It's not used. So nobody uses it. Plus D is a special. It's for broadcasting. I'll show you now. So that's plus C. And plus C is used for multitasking address. Plus E is reserved. All right. So those in the exam, maybe I will ask you about them, but that's what we have. All right. So now let's talk about plus A. So plus A, how many networks you can have? Remember, how many bits you use for network ID? 8 bits. Now the question for you, how many bits can change from the 8? How many bits you can play with change from 0, 1, 1, 7? Why? Remember, the plus A, the first bit always is 0. So this 0 always stays. So how many bits you can use to represent your network ID? 7. How many networks you can give? How many networks? How many organizations you can give an ID address to the plus A? 2 to the power 7. So only to the power 7 organizations we can have network ID. So how many organizations we can do? 128. Is that enough? Is there only 128 organizations in the world? That's why plus A is not used, because plus A gives you few organizations. However, each organization will have a huge number of IPs. So how many IPs you will have in each part? 16 million. Do you have an organization that has 16 million devices? No. You will not have it. That's why plus A is a waste of ID address. We have only 128 organizations, and each organization will have 16 million ID address, and maybe around 17 million. So it's a waste of ID. So that's why nobody uses plus A. So how many net ID will have? 0 up to 127. That's 128 block ID. Each block, how many IP addresses we will have here? For this block? Each one. 16 million, almost 17 million. All right. That's a class A. It's a waste of IP address. So million of class A addresses are wasted. Now let's go to class B. Now class B, how many bits we always sustain? 2. And how many we change it? 14. So remember, the first 16 is for the network ID of class. Now When you look at first two, always it's 1 0. Oh, then how many bits left? Okay. So how many blocks do you have? 2 to the power 14. How many organizations we can? 15,000. 16,000? Yeah, 16,000 organizations, right? Now, each organization, how many IDs? 2 to the power 60. Right? 60,000, 65,000. Still, it's really hard to find an organization that has 65,000. So that's why again, class B is a list of ID. So nobody is using class B already. Now, what is the next one? Class C. Class C. How many bits is fixed? First of all, how many IDs, how many bits for the network ID? 24. From the 24, how many bits always fixed? 3. So how many bits from the 24? So how many blocks we would have? 2 to the power 21. So how many organizations we have? You know, it's gonna be 2 million or something, correct? Almost 2 million. Let's say 10 million. Now, each organization, how many IDs do we have? Only 256. Why? Because we're using all the blocks. Now, in the organization, we have only 256,000. No, that's small odds. So class C by itself is not a wall. So that's why we use something called super. What is super? We'll see that. When you combine two, the class C to make it bigger. You know, we have 265. Okay, what you can do, you can merge 2 together. Now you'll have 5 blocks. You can merge 4 of them, and you will have 1,024 devices. So that's called super. So we'll see. All right. Is there any question so far? Not so many organizations are so small to use the class C. Perfect. Now, class B, as we said, it's 1 o'clock. 1 o'clock, how many IP addresses they have? 268 total. Class B addresses are made of 1 o'clock used for multitasking. That we will learn it later, you know, that's about the multicasting. The last one, class E, it's 1 o'clock and has how many IP addresses? 268 million, and that's reserved for future purpose. So nobody is using class. So, all right. The range of addresses allocated to an organization is a class code. So, any organization we can use A, B, C, D. We cannot use E and B somewhere. All right. So as we mentioned before, IP address is divided into 2 sections: network ID and host ID. So the first network ID is represented by n bits, and the host is 32 minus. So now, if you have class A, what's your n? 8. Class B 16. Class C is 34. Now we can tell you how many bits represent the host. Going to be n minus 32 minus n, and so on. You can do the math by yourself. You don't have to worry about this diagram even. Okay. So why we need the network ID and why we need the host ID? It's the same like the phone number. Phone number, when you call a number, you will like that's the area part. You will have something. That's why it's kind of organization, how to organize your communication. All right. What's the time? Well, almost there. So now, the question now, if I give you an IP address, I will tell you what is the, if I give you a random IP address, what is the first address in this network ID? What is the last address? Can I do that? Yes. So simply, if you want to find the first IP address, how do you want to do it? The first IP address in this network. The network ID is going to be the same for all your IP addresses. What is going to change? the host ID. Host ID, the first host ID start with 0000. The last one, it's end with 1111. So, and what's some of the math you can tell if I give you an ID address, I'll tell you what is the first ID address, you should be able to. What is the last ID address, you should be able to. Right? And I will show you now some example. So in any class, I can give you an IP address, and you should tell me what is the first address and what is the last address. Simply, as we mentioned here, the first address, all the host ID is equal 0. The last address, the host ID, or everything is 1. And you can do the math. I will show you now an example. All right, so let's do some exercise. If I give you this address, 73221725, and I ask you, find the number of addresses in this block, the first address and the last address. First of all, the first step, what do you have to do? Find the class. So what is the class? Class A. Class A. So how many addresses in the block? Class A, how many addresses will this be? So what is the network ID? 73. The first is how many ID addresses you can understand? First of all, 24. 24. The remaining, that's how. That's why you see here how many addresses you can have. 16 million. Why? It's to the power 32 minus 9. What is the n? 8, because it's plus 8. That's why. First of all, you have to go. You can find what is the block. It's A, and I know that n equals 8. Then I can find how many addresses we have. It's a symbol to the power capital N, which is 32 minus, and it's 8. It's 2 addresses. That's the first part. Second part, what is the first address? First, I remember what I would do. Network ID, I will keep it the same. Then the host ID, what you want to do, make all of them 0. So let's do it here very quick. So what is the network address here? 73. So what I have to do? I have to make everything else. So what is the first address will be? Perfect. Now let's find the last address. How you find the last address? You keep the network ID the same. Then everything else equal 1s. So 1s, what mean if you have 11181 ones, 255, that 255, that 255. Perfect. So that's the first address, that's the last address. Perfect. So that's why we have here, and that's the address here. So okay, so yes. So that's why in this network, what we will have, we know the network address.
కాళ్ళు ఆడుకోలేవు ఊరంతా జమానంతా తిరిగి వచ్చి కాళ్ళు ఆడుకొస్తాను.
How many times I am muted? Why the yeah, all right. So we know that the range starts from 000 up to 255, 255. However, the 000 represent the network ID. You know that's your network ID. Then you have all these ID addresses. The last one is a special. That's for broadcasting. So nobody can use this ID. All right. So in the exam, if I ask you how many ID addresses is 2 to the power 24. Okay, what is the network address? Is 730000. What is the special address? Is 73252525. Perfect. Easy. So let's do another example. In this example, I'm giving you this address 180.817.9. Find the number of addresses. Okay, first of all, the first step, what I have to do? Plus 2. Okay, how many addresses do we have? How many ID addresses do we have? First of all, remember, class 2, the first 16 for network ID. Then yes. So how many hosts we will have?
Oh, I had class early.
2 to the power
Oh.
6
Oh.
minus 16 minus 16 is 16. That's the number. Now, give me the first address on last.
It's okay.
Ah.
That good.
Okay, what is the first address? So remember, we have to keep the network ID same thing. And so what is the network ID here? 180.8. And what is the remaining? I will change it to zeros. That's the first address. What is the last address? I will keep the network ID the same. Then I will make everything else ones. So it's going to be 255.255. So that's the last address. So that's why it's here 255, and here we'll have 18. Now, if I ask you the same question for a class C, do you think it's going to be hard? Should be easy now for you. So same thing. Here, my network address is the first two zeros. Special case is 255 to 55. And between them, that's the range, my range. All right, let's do another example. That's class C. You can tell right away. How many hosts do we have? 2 to the power 8. So 26. What is the first address? Can you tell me? 200, that's 0, that 11, that 8 dot. What is the last address? 200. No, it's easy. Okay, the same thing. What is the network address? Is 0. What is the special? 255. And between them is the my range. How many IP addresses here do you think we have? 254. Right. The video we have 256. For the first one is for the network, and the last one is special. So 254. We're almost there, guys. If you give me like another 20 minutes, we'll be finished. I'm kidding. Quick. So now, here, just give you a diagram. So, as we mentioned, each organization, we have different settings. Maybe class A, class B, class C. Can everybody talk to each other? Even if I am in class A, can I talk to class B? Yes, yeah, you can. Different networks. So, that's why that's one of the networks. Can you tell me what is this one? Which class? Class C. How you tell it's class C? Two things. When you see /24, the 24 is for the whole city, it's class C. And 220, when you put the 20 is class C. So this one is class C. What about this one? That's class B. You can tell it from the 16. What about this one? This one is kind of the internet, for example, or maybe one of the internet provider. What type of class we are using here? Class C. Right? So that's why you can connect to the other networks because we have routers. Router will do the job. We will do that translation. That's how the network looks like. The network address is the identifier of the network, as we mentioned. So in the router, maybe I can do that. Yes. So in the router, so if you have a router here, so this router, how many interfaces has? A lot. I don't know how many. 1, 2, 3, 4, and N. How many networks are connected? M networks, correct? So in the router table, the first step, you have to know what is the network ID. So when you have a packet, you want to send it to a network, you don't have to worry about what the specific device. For me, I care about the network ID. I want to send it to this network. This network, when you receive it, we can. That's very good. I'm not going to wait. For me, I want to deliver to the network, and network will do that. Perfect. So what I will do in the routing process, I will have the destination. All right. So from the destination, what I will find? The network identifier. So how do I know how we will find the network identifier? Simple. It's a class A. The first thing
the plus C is the first 16. Plus C is the first 24. So from here, you will know what is that network address and it's connected to which interface. So when you have a packet, it's gonna come here. I will look if it's plus A. I will just care about the first one, and it's connected to not the interface. If here it's plus B, I will check the first two. Then I will send it to you. If it's a class C, I will check the first three, then I send it to you. So that's not the job of the router to do that. All right. Now, how we will find the network ID? So there is a process called mask. So the mask, so for example, for class A, what is the mask? The first 8 bit is 1. So that means I care only for the first 8 bits. Remember, if you add anything with 1, what's that result will be? I'm sorry, no, if you add it with 1, what's the result? The lowest number. So you will if you add it with a number, that means I will keep the same number. I'm not going to change it because if this number is 0, that means the answer will be 0. If it's 1, let's make the answer 1. So the ones I'm trying to ignore everything else, I'm just focusing in the first 8 bits. So that's why for class A, what is the mask? 255.0. What about the class B? It's gonna be 255 to 5500. Then here 255, 55, 5500. So now if I give you any ID address, okay, for example, let me make it here real quick. If I give you IP address, for example, 10.200.15.11, okay, so I know that is class A. So what is my mask? 255.0.0.0. Can you tell me what is the network ID? You're ending them. So what is 11 and with 0? 0. 15 with 0? 0. 200 with 0? 10 with 25? 10. Correct? So now what is my network ID? I'm sorry, 10. So the router will do this job. Router, to know what is the network I'm looking for, because I will be sending and read the mask. That's why we need the concept of the mask. So the methods we describe basically extracting the network address are mostly used to show the concept of network mask or default mask. All right. So we heard about the mask. Then we heard something. I'm sure that's what we use this day. Subnet mask. All right. We heard about it. And we will see that there. But the default or the mask, that's the one. For class A is 255.0.0.0, class B 255.255.0.0, and a class C. So what is the router will do? As we said, I have the IP address and I have the mask. Then if I add them, what's going to happen? Then I found the network. That's what the router do. All right. So a router receives a packet with destination address 201.24.16.32. Show how the router find the network address of the packet. Simple, because we are talking about class 4. When I look to the 201, what this one? Class ABC, class C. So what is my max? 255. No, class B. That's class B. Plus A from 125, 128, 191, that's plus C. That's one. So anyway, so that's plus C. So plus C, what is the mask will be? 255, 255, 255. And 0. So what's the result will be? 201, 24. 67. So that's not very good. So in the exam, I will give you an IP address. Okay, I'm going to tell you that's a class, right? So then from the first 8 bit, you have to know it's A to C. And you will know if it's A, then I have to Maybe do the math. So it's gonna be multiple choice. All right. Now let's talk about very quick, almost done. I promise you guys. Now subnetting. As we mentioned, if you have a network and it's a class, for example, class has a lot of IP. So what you can do, you can divide it to a smaller network to organize it to maybe have more security. So let's say now you have a big organization and you have one section is the network. You have to add more security. Right? So what you have to do, you don't have to secure the whole network. What you can do, you can divide it to small core networks. And let's say I have one big one, you can divide it to four. One of these I have to add more security. So you don't have to do, you don't have to waste your money to do security for all. You can focus on it. That's why we have a method called subnet. We divide our net from the name subnet. So the name for small subnet. So there's so many reasons, you know, but that's really mean, you know, to make it more organized. So how you do subnetting? So let's say, oh, that's my network. So this network, what is, first of all, from the address, what is this one? Plus B. So how many addresses do we have here? A lot. Correct? It's 2 to the power 16. A lot. So now all of them in the same network. So what is the network ID? It's 141.14.00 because the first. Now, you can divide it to a small one. How you can divide it? You can add another router, and this router divide the traffic. How you can do that? Okay, so what we did, we divided to 4 small networks. So each network we call subnet 1, subnet 2, subnet 3, subnet 4. Now, how many initially before we divided? How many network ID we have? How many threads for network ID? 16, correct? The first 16 is represented. Now, if you want to divide that here. Number 4, how many bits you need to represent 4 of? 2 bits. For example, 0, 0, that's network 1. 0, 1 is network 2. 1, 0, 3, 1, 1, there. So in this case, what you have to do, from the 16 bit, remember the 16 bit? Correct? What you have to do? From the first 16 or the next 16? From the last 16. So you need 2 bits to represent this subnet. So that means how many bits you need to represent this subnet? 16 bits enough? No, I have to add another 2. That means I'm taking 2 bits from the host ID. I'm using them as an identification. I have to take it from the host ID and add it to the network ID. So network ID has to be. So now using anything that will represent 4 networks. So in this example, if you see this one, the first subnet. So what I did, remember what is the, let me write it down for you. It's going to be confusing, but it will be easy now when I explain it. Okay, so initially, what is the subnet network? It's 141.14, correct? Then what is the first IP address? Is 0.0.0.0.0.0.0, correct? Then 0, correct? So now, if you want to do a subnetting, what I have to do, I want to take the first 2 here. Those will be represent my subnetwork. So what is the first subnetwork? What is the first IP address? You will keep these 2 zeros and everything 0, correct? So what is the first subnet? It's the same. It's going to be 141.14.0.0. What is the last one?
You remember the first 2 bit has to stay the same, right? So that's mean the last IP address 141.14 dot. I have to keep this zeros. Then I will do 11111.1111. What is the last IP address? It's 141.14 dot. What is that? Those. Add them together. I don't know what those. It's gonna be 63. That's 63 dot 255. Perfect. So that's the first subnet. The first subnet network here. What about the next one? So the next one is really simple. Simple. What you have to do, the 01 will make it 0. I'm sorry, 00 will make it 01. 01, correct? So what is the first IP address? It's gonna be 141.14.101.000. 64, it's 64, correct? So it's 64.0. That's the first IP address. Here, you see here? Perfect. What is the last IP address? It's the same thing. It's going to be 141.14. Remember, we say 0, 1. That's always going to be the same. Then after everything else is ones. 1, 1, 1, 1, then dot 1, 1, 1, 1 dot 1, 1, 1. I'm sorry, there is no that thing. So what is this number? That's 127. So the last IP address here is it's 127.55, correct? So the short story here, I took two, again, here I divided to how many networks? Some networks. We divided to 4. That's mean you only 2 bits. Let's say in the example I told you I want to divide it to 8 networks. So how many bits are we? So how many, what is dual network ID? Can be the original network ID plus 3 bits. So the 3 bits will control how many. There is a equation. I will show you. Almost there. Okay, so here, that's your original network mask. It's network ID and the remaining bits. Now, let's say now I decide to divide it to 4 networks. So how will find out how many bits for the subnet ID? Simply, it's going to be n plus log 2 of how many networks? In our case, we say 4 networks. So what is the log 2 of 4? 2. So that means we need 2 bits. And my network was plus 3. So how much total I need? 18 bits. So simply, that's the equation. You want to find what is the subnet ID? It's going to be the original network ID plus log 2 of how many networks you want to divide the bits. Right? Okay, that's an example. Here, I have a class network B. I want to divide it to 4 networks. So what is the n? Original n, 16. And what is the new n or the subnet ID? It's going to be 16 plus log 2 of 4. Yes? 15. And you can find the first address and last address. That's easy to do. Now, okay. You can here find the new network ID, but I'm not going to discuss that now. We talked about if you have a big network, you want to divide it into a small network. Now let's talk about the problems. If you have a small network, you have to balance it. Then make it bigger. So how do you do the opposite? The plus C, I would have 265. I'll make it bigger. I need 5 4. Simply what I have to do. I have to take some of the bits of the network ID and use it for the host. And that means I have to minus. So for example, that's my default. That's what I was the process. See. Now, if I want to do subnet, what you have to do? you added 3 bits for network ID because you divided. Now, if you want to do supernet, what you have to do? I will do supernet. I will use some of the network ID here. Use it to add more IP addresses to the that is called supernet. How you find the new N for the supernet? It's simply N minus, log 2 of the, how many blocks in it? Simple, obviously. What else we have to cover here then? That's a lot class for today. Is there any question? What we covered today, it's really chapter 4, so it's talk about the network. Network layer, we talk about connection orienting, and it's really a simple chapter. And chapter 5, we cover the class 4. Believe me, nobody's using class. Everybody now using class. Okay, so next week we'll see you. I just added the deadline for the assignment 1, 2, 3. It's a Friday for 3 of them. So try to finish them on supplement, please. Thank you, guys. See you next week.
See you next.
Thank you, guys. See you.